In general terms, all lathes have two basic groups of controls: the controls that govern the spindle speed and the controls that move the cutting tool. On combination machines that use one motor to power both the lathe and the mill, there's a third control. This control is the clutch mechanism that transfers power to either the lathe or the mill. On this Granite 1324, the control lever for the clutch is here. On other machines, it's located inside the gearbox on the end of the main drive pulley. These clutches can only be shifted when the motor is turned off and the machines are totally at rest. Now, determining the correct spindle speed in RPMs depends on the type of metal you're cutting, the type of material the cutting tool is made of, and the diameter of the workpiece you're cutting. Harder metals, metals that are tough to cut, are turned slower than those that are soft and easier to cut. Large diameters are turned slower than small diameters. Charts that outline the recommended cutting speeds for various metals can be found in a machinist's handbook. The carriage assembly and the power feed system control the movement of the cutting tool. In a facing cut, the machinist will use the hand wheels on the carriage and cross slide to position the cutting tool to take the first cut. The depth of the cut is then set by advancing the compound. Before the motor's turned on, the power feed system has to be adjusted so that the tool travels in the right direction and the right speed. The speed at which the tool travels is called the feed rate. When everything is set, the motor's turned on and the cross slide is engaged to make the cut. Here we're cutting steel with a right-hand facing tool. On a lathe, feed rates will vary depending on the depth of the cut and whether you're doing a rough cut or finish cut. In a turning operation, the depth of the cut can be set by advancing the cross slide. The carriage is then engaged to feed the tool along the workpiece and make the cut. For most lathe operations, the machinist will make a few rough cuts to bring the material down to within about 1/32 of an inch of the final dimension. Rough cuts are usually heavy cuts with no real concern with the finish on the part. The object is to remove as much material as possible in the shortest amount of time. When the rough cuts are done, the dimensions are checked and the machine is set to take the finishing cuts. Finishing cuts are usually done with a separate tool designed just for that purpose. The depth of the cut is usually small and the feed rate is slow. The time it takes to make the cut is less important than the dimension and the finish on the part.